Okay, we did this. We don't know the conditions for this. So see if this flows are like that, therefore it has to be like this. And when that happens, this goes like that. You see those two are flows, and then it needs an effort here. So then it's like this, and then you finish. So this is my electrical circuit. Ready to do something else? Let's see if we can do that next. Let's just okay, I'll leave it in there for a moment, or if you are copying it, make sure that you get it right on your notes. And that's the electrical circuit. Okay, we will, I think now we need to, perhaps I think we should save this file, I believe. Yes. So save as the pictures. I think entitled, let's call it entitled 2, because I think we saved the picture before this. Okay, once that happens, then I'm free to do this. See? Oops. Select. Select all this and click delete. And now I have, like, if I have erased the board. So I think we should try something else. Try other example that let's try a variation of the previous one. But let's say that in one of the loops you have two elements in there that give you that see the difference in current. So we could give it a try to this. Let me see if I can draw it. Let's say you have it now similar like that, and now you have a loop that has two of this in parallel like this. See? No, this is the inductor here, and the other one is a capacitor on this side. Just to right. Let me erase this for a moment, and it's the beauty of this thing is the work as if I'm working on the board. Okay, so let's try this one here like that, and the other side one like this. Okay, let's erase this for a moment so it's all right. Very good. And then we have something like this, but this time on this side I'm going to have a capacitor like that, and this one will have a resistor here. So you have an L1, and this is an L sub 2, this is an R sub 1, this L sub 3, and this C sub 1 and C sub 2. That's what we have. Okay, again, let's start with the current. See, this is I sub 1. You will have I sub 2 over here. And you have I sub 3 like this. So in here we could consistently will put those ones in red. So let's say that one, this other one also, so 1 I sub 3. Then we have this one for I sub 2. And that makes the skeleton of our boundary model, because the next we have to see what elements experience this. So this current. So the first one is this one, which is a voltage source of AC in this case. Right? Yeah. So we put this one junctions for each current, and let's just put the elements that see those currents. So this one is an I with L1. Then you have on this I1 over here the C element. Okay, so that's this guy. And now in here, the interesting thing is that the difference in it exists like this. This would be another what can I say? This would be if it is another circuit, yeah, another loop, excuse me. Or you could see that the difference in current L sub 3, I sub 1 and I sub 3, which would be the zero junction like this, it would be I sub 1 minus I sub 3. That's this one junction. And in here, this C is this I element here, and this C element over here. And then you have I1 minus I sub 3. Yeah. I1 minus I sub 3. So then we have this element in here represented over here, so this is fine. So in between I1 and I sub 2, there's this L2, so this will have to be like this, and then this is I sub 1 minus I sub 2, and then this obviously has this I element with value L1. And we're almost done. So you see, if you follow the steps, it really helps. So between x2 and x3, so in here you have this R sub 1, and that's the end of this. Let's give it a try to the causal marks to see if this is not much of a problem with this. This is an integral form like that. And in here, this one is an integral form. So Okay, I think we are all done now. We were here. Sorry, for a moment I was thinking what I was gonna do next, but here's that makes this one to be like this, and in doing so makes this. And what do we do now? Here's one in integral form, so the other one also in integral form like that. Okay, and so just thinking here, this is all complete. The C is supposed to be like this, and in doing this, this is also the case. Because of these two flows, this has to be like this, and now we have a working system. Okay, I hope this gives you a good idea to practice for your quiz on Thursday, and maybe this will be helpful for you in that regards. I wish you good luck on the quiz. This was just to illustrate some of the procedures. So what I would suggest that you do is study those procedures really well. Look at the examples on the textbook, give them a try, and see if you can do it yourself. I think chances are that if you do that, you'll do really well. I wish you good luck on the quiz on Thursday, and hope everybody does well. Okay, bye guys. You can go now.